welcome everyone today to CleanStart's Perspective. We've got a good one today. I'm really excited about it. It's actually part of a series that we're doing focusing on water. Now, first off, I want to start by recognizing our sponsors. That's SMUD, our local utility that is very concerned about water because they get a lot of their power from hydroelectricity. CleanStart up north, which is also part of the Central Valley's agricultural basket and a partnership with Fresno State. You got the north and the south of the Central Valley there that are very centered around agriculture that is reliant on water. Witten Law, if you have an idea and you're building an early stage company, I highly recommend you go talk to Douglas Bosley there. Also, Moss Adams, our local accounting firm that works with early stage companies and has helped a lot of them, get their finances in order so they can fundraise a lot of money. And River City Bank, which has done countless renewable energy projects in the state and is a leading partner in developing them. Now, with that, I want to just quickly highlight that we do have two more discussions coming up around water and innovation. California's agricultural sector is about $55 billion, and it contributes over $100 billion to the state's economy annually. It also uses 90% of our water, or 90% of the water that it uses does not go back into the environment. And with climate change increasing the frequency of dry years, investment and innovation in how California uses its water is critical for the economy and the quality of life of California. Now, I'd like to welcome Dr. Charles Hillyer, Director of the Center for Irrigation Technology at Fresno State. The Center for Irrigation Technology supports developing and deploying technologies that will bring the world's most innovative products and resources and resource management tools to businesses and to the community. The center is built on a foundation of innovation and technology transfer focused on testing, applied research, and entrepreneurship. Since 1980, the Center for Irrigation Technology staff has worked with the public and private sectors to advance irrigation, water, and energy technologies and management practices. And with that, I'm going to let Charles Hillyer introduce himself and take over the sharing.
Okay. Thank you, Thomas, and thank you to CleanStart for inviting me to speak here today. I think this came out of a conversation that we had a couple of months ago about perspectives on irrigation and what's happening and what's needed in the industry. So I've got a slide deck here that's really just 2 slides. And if Zoom will cooperate. So what I'm going to talk about is basically a couple of points about trends that I see happening and some that I'm actually participating in relating to opportunities and issues in irrigation with a focus on agricultural irrigation. And the next slide, if there we go, is basically just talking points on this slide. But the first thing is, who are the customers? Who are we trying to reach? And when I say we, I'm talking about the research community and the entrepreneurship community, but particularly the research community and universities in general. A big part of my focus is about automation and applying it and getting the most value out of it and how that can improve our resource uses. When you adopt automation technology, it opens up new management opportunities. For example, if you have a fertigation system where you're injecting fertilizer, that can make you a lot more efficient. But if you automate that, where you don't need to be physically in front of it, pouring things into tanks and pressing buttons, if you can do that remotely and you can do it programmatically, you have the option to start doing spoon feeding fertilizer, which is a much more efficient practice. And that sort of management practice is really only practical if the system's automated. Instrumentation is also usually lumped in with automation. And if you can remotely monitor through weather stations or soil moisture probes or pressure gauges and flow meters, getting access to that data remotely opens up new management options, but only if those data are translated into something that's actually useful. So these two, sort of automation and instrumentation taken together, they produce two benefits. The standard benefit, the benefit that you see used as a justification in regulatory agencies or research programs, is improved resource use, greater efficiency, greater sustainability. But it produces another opportunity, which is a way to facilitate new business opportunities. A lot of these new management options are something that the user has to figure out themselves. You've got to recognize that spoon feeding your fertilizer is an option, but then you've got to actually go out there and do it. Making that easier for the end user is still a bit of a challenge. And so this opens up an opportunity, but it means that we, the research community and the universities and the extension service, need to look at a different group of customers, right? Which is the firms that offer these services. A lot of our extension focused activity is focused on growers, the end users of these technologies. But in order to make these automation technologies exploit the new management options, the way to make the instrumentation produce actionable information means having extra management components in these software services. And that means addressing the companies directly on how to build these things, how to use them, providing them code that they can plug into their existing applications, providing training to those companies on how to make the most out of these management algorithms, and facilitating demonstrations of these applications at universities and cooperating farmers. It's a bit different from the technology, sort of the stereotypical technology transfer activity that happens in universities and research centers, where you're working with a professor or a researcher who's come up with a good idea and they're trying to translate that into something growers can use. This is more about getting the companies to adopt it rather than getting the farmers to adopt it. And from my perspective, startup companies are sort of the low-hanging fruit in that technology adoption scenario. Startup companies have a lot less inertia. They're a lot more hungry, for lack of a better word. And so I think it's easier for them to take on this new management algorithm or a new batch of code or something like that, because they're not having to fit it into a much larger product offering or much larger service offering. They're also less risk averse. The risks, the liability risks associated with management software, those liabilities are not trivial. And having a greater affinity for risk is something that many startups have. So from my perspective, the startup companies are an opportunity for research centers and universities to move their research products into the hands of the growers, and those startup companies become a partner or a channel to get those new management algorithms baked into existing products and service offerings. The next point is about designing for climate change or climate smart irrigation. One thing that I often say to people who aren't so familiar with these issues is to make a distinction between weather and climate. Climate is what we expect, but weather is what we get. And the climate helps us understand what things might be like. They sort of establish these boundaries between the realm of the possible outcomes that we need to address. And it's a problem in irrigation system design because the current tools make an implicit assumption. They assume that the future will be like the past. From a statistical perspective or statistical language, this is called the stationarity assumption. And it's pretty fundamental to a lot of the statistical methods that we would use to design an irrigation system, particularly sizing the irrigation system. There aren't many tools available that make it easy for irrigation system designers to incorporate the uncertainty about climate in their irrigation system designs. And these design firms have to balance two almost competing goals. The first and most important to the design firms is to build or design something that the clients will be satisfied with. And so there are a lot of balancing activities that are involved with talking to clients. But if they want to design something that's also climate smart, they also have to incorporate the climate uncertainty in their analysis. And that's difficult because doing things with statistics that don't make stationarity an implicit assumption is really hard. Non-stationary statistics are over my head. And there aren't that many design algorithms or statistical tools that take this into account, specifically for irrigation. That's a challenge for the irrigation community, is coming up with tools to take climate change explicitly into account. And in order for that to move forward, we actually need collaboration from outside the irrigation industry. We need help from mathematicians and statisticians. These are the folks who live and breathe this sort of thing. And we need more collaboration from them to translate those sort of theoretical understandings into practical tools that designers can use. The last thing is about data and irrigation efficiency. Management is the largest determinant of irrigation efficiency. We often focus on the efficiency gains that are associated with adopting a new technology. And in many cases, those efficiency gains aren't really the irrigation efficiency, they're the application efficiency, which is how efficient does the water come out of the device and stay in the soil. But irrigation efficiency is how well are you managing the water over the whole season. So rather than an individual irrigation event, irrigation efficiency is about the whole season. And the decision making is what determines, for the most part, how efficient you are when you're managing the water. So having more data, having better data, usually means more time thinking and analyzing and doing that management. So adding new instrumentation, adding new data streams to your management practice doesn't always result in more management, better management, but it does always result in more work for the manager. And that's an obstacle to getting these better management tools adopted. These tools have been around, many of these better management tools have been around for years, but the adoption rate's pretty low. If you look at the Farm and Ranch Irrigation Survey that happens, I think, every 5 to 7 years, one of the questions that they've been asking consistently for the past 25 to 30 years is, what methods do you use to decide when to irrigate? And the methods that are based on perception, the feel of the soil, the appearance of the crop, what your neighbors are doing, those are still the dominant methods used to decide when to irrigate. Now, there is an upward trend in the adoption of soil moisture sensing technology and weather stations and management software, but there still isn't parity between the perception-based methods and the objective or the scientific irrigation scheduling methods. And from my perspective, having built some of those tools and worked with them for quite a few years, part of the obstacle is these tools don't make the data management easy. Right? You've got to spend quite a bit of time making one system talk to another system, or copy pasting things from one Excel spreadsheet to another, and then doing a lot of your own calculations. Some of these tools make that a little bit easier, but for just one particular type of technology. There's a big variety of technologies that can help your management become better and help you do a better job of making the most of the water that you have. But a lot of these tools don't work well with each other. And that data integration, that systems integration and data management is getting better, but it's still not something that's the norm. The other issue is that these tools don't always generate actionable recommendations. One sort of eye-opening moment that I had when I was working in Texas was working with some growers that had started adopting soil moisture sensors. There was a vendor in that region who made it really easy for the growers to adopt soil moisture sensing technology. And they basically made it a service, right? Where the grower would pay an annual fee and they would just receive the soil moisture data. The vendor handled the installation, they handled all the technology. The grower didn't actually own the sensors, they were paying for a service. And the comments that I got from quite a few of them were that the soil moisture sensors were basically showing them that the soil was dry, which they already knew, right? They already knew that they didn't have enough water. And so the soil moisture sensor was really just confirming that. There was one presentation where I was talking about soil moisture sensors, and one of the growers spoke up and said, this thing's telling me I need to irrigate. I already knew that. Why am I paying $700 a year to find out something that I already knew? And that's what I mean when I say that many of these tools don't always generate actionable recommendations. They produce the data that you would need to generate a recommendation, but they don't actually tell the grower when and how much to irrigate. And they're not taking all of the externalities to soil moisture into account. If the soil moisture sensor says, you need to apply 1 inch, well, I've only got a quarter. Should I just turn the water on and leave it on? Or can I hold back a little bit? How do I strategize my water applications? There are algorithms that can help do that. And some companies are starting to offer those algorithms implemented as a service, but the adoption's still not very broad. So we've got these sort of competing problems here where you've got data management stuff that's pretty boring from a science point of view. There's system integration issues, but that's challenging because you've got different companies that may or may not want to integrate with each other. And you've got these algorithms that could actually tell growers, you need to apply 1 inch, but hold off for a couple days. But offering those services introduces new liability concerns for the various companies. And I think all those problems taken together are part of the reason why we're not seeing broad adoption of scientific irrigation scheduling technologies. And it's data management, it's systems integration, and it's also irrigation algorithms and helping people to understand them. And by people, I mean the companies that might adopt them. So for irrigation innovation and what do we need? We need more automation. Automation is going to open up a lot of opportunities for better and more efficient management. We also need to start looking at autonomy. From my perspective, there's a big difference between automation and autonomy. Automation means if I can turn the buttons on using just my phone, that system's automated. But if I need to physically drive out and turn a valve or press a button, that's not quite automated. But if the system turns itself on, if the system deciding when to open the valves and how long to run the system, that to me is autonomy. And I think autonomy is going to be the next big thing, but we're quite a ways away from it, because to make that autonomy work, you have to have algorithms that people trust and that actually work and have been demonstrated to work and would work in a reliable and safe way. We're getting there. There's active research happening in that topic, but that's in my mind the next big hurdle. And it's more than just a technology hurdle. It's a research hurdle and an intellectual hurdle as well. The other thing we need is systems integration. We've got a lot of nice technologies out there, but they don't play well together. And increasing systems integration is going to make these new management options a lot easier. And then lastly, or second to last, is advanced statistics. Dealing with non-stationary statistics is hard. And we need collaboration from statisticians and mathematicians to come up with ways to make that easier for the people that are going to use those statistics. And finally, is management algorithms. There are lots of management algorithms out there. They've been around for a long time. Most of the times that I see those algorithms implemented into a tool that a grower can use, it's coming from a research group or an extension center. And those tools are good, but long-term support needs to have some sort of, for lack of a better word, a service provider who's going to deliver that over the long term. And in order to do that, it's got to be well financed. It's got to be something that growers are willing to pay for. And but implementing or designing and adopting those management algorithms usually requires a high level of technical understanding. And so that technical understanding needs to be sort of baked into code that companies can adopt more easily, more readily, with less obstacles about intellectual property and less issues associated with the liability if the algorithm doesn't quite work. So in thinking about needs and opportunities, those are the things that I look at often: automation, systems integration, advanced statistical methods, and management algorithms.
Uh, just that?
Yeah, it'll be easy. Few days, we'll figure it out.
Well, I've got some questions for you if you want to stop sharing, and we can move on to the
Sure.
discussion portion of it. First off, I do want to share in the chat. We had a chat with a startup out of the Bay Area that was on combining weather and climate data to make forecasting. So if anyone's interested, they can go and check that out online. But my kind of first question for you is, you started off there with like the problems of adoption, and then later you mentioned that they're using basically touch and feel and looking at their neighbors to figure out what they want to do. What are some cases of, I guess, successful adoption you've seen out there, and what has made them successful?
So I've interacted with and worked with a few growers that have a high affinity for technology. And often in those cases, one of the things that I see is that there is a person or persons on the farm who have the affinity for technology. You know, they having 40 apps on your phone to manage various aspects of your farm. If you're okay with that, you're the tech person, right? And you're going to be the one who's making that work because you have an affinity for technology. A lot of people don't. There's nothing wrong with that. It's, you know, it's not I don't see it as a personal failure or an inadequacy. It's a preference. Having to tweak all the buttons and play with all the widgets is not something that everybody wants to do. That's where automation and autonomy can really have a strong impact. But that adoption success from what I've seen is usually because there is someone who really likes this stuff.
Well, I guess that's a good way to do it. What about, a lot of the things that have been talked about on, reducing water waste has been kind of, we'll fine you if you waste water, or we'll put, regulations more of a stick. What are some of the opportunities that, I guess, proper water management could bring a farm or bring agriculture? Is there a point or a way to convince them, hey, you can make more money at the end of it with this technology?
Well, the revenue motivator is always going to be the number one motivator, right?
Hmm.
And one of the convincing or motivating people to increase resource use efficiency has to be not exclusively driven by, but mostly driven by the revenue consequences of doing that. Early on in my career, I worked with a really innovative grower in Oregon, and he said something in a meeting that stuck with me my whole life. He said, Charles, you're talking about conservation. Growers aren't conservers, we're optimizers. You know, we're trying to make the most out of what we've got, not use less.
Hmm.
One of the issues with promoting conservation is that you're trying to convince someone to use less.
Hmm.
There's got to be a revenue benefit from doing that. If I don't use the water, I don't generate revenue from the water. And that's not really a science issue. It's a policy issue. It's a regulatory issue. There's got to be some way to either get some revenue from the water I don't use, maybe by trading it or selling it, without jeopardizing my ability to use that water in the future.
I think when we talked earlier, one of the things you said is no one has ever been fired for overwatering,
Yes.
which I think says volumes. Now, you just mentioned there, being able to trade water. I know in the past, there's been a couple of groups that have tried to make water trading platforms in California. And I believe there's some internationally, but I'll be honest, I haven't looked at it recently. Are there like places where people are able to kind of trade water like we imagine we could do with carbon credits? Or how would that even work in a system? Because if I have excess water, I can't exactly send it to Chico.
Yeah, that what you just said is part of the fundamental problem of water markets. They tend to be regional. You know, it's especially when it's about groundwater, because the aquifer that I'm standing on top of is not the same aquifer that's back in Fresno. So the spatial issues make water markets a bit more challenging. Also, trading water futures is additionally complicated, because when you irrigate, you're not irrigating with a water future, you're irrigating with the water. And so if I'm going to have a water market, I need to be able to actually receive the water that I'm buying. And if I'm selling water, somebody else needs to receive it. And the regulatory boundaries, the sort of the spatial boundaries of the regulatory agencies make that even more complicated. So you're right in that water markets do exist and they've been successful, but the ones that I've seen that are successful tend to be regional, because having water cross boundaries usually requires a large government being involved.
Mhm. We've got a hand raised from Dan Kellen, one of the Clean Start members. Dan, do you want to come off mute and ask your question?
Great, thanks for the opportunity. So quite a while ago, I was advising a startup that was doing evapotranspiration measurements in fields to help regulate water use. And the comments that they actually received from farmers was that their expense for water usage was very small compared to labor usage or labor expense. Is that a true statement, or is it still true? And what the startup found was they could actually sell their systems more on the premise of regulating how much canopy was generated, so it would actually reduce labor expense rather than helping the reduce water use. Just interested in your comments about that.
I've heard that too. Excuse me. Oftentimes when people look at the expense of water, they're looking at how much is the next acre foot going to cost me? Or how much is this irrigation event going to cost me? And when you compare that cost to the cost of fertilizer or crop protection, it's usually an order of magnitude difference. But I think that if you do that, you're looking at the wrong time scale. You've got to look at the whole season's worth of water use for the whole crop. If you're growing an annual crop, it's the whole amount of water that you applied over the whole year. When you look at it in that scale, or that time scale, and you look at what you get for that water, the revenue that was not possible without the water, the cost and the magnitude of the impact are quite a bit larger. Labor is going to be more expensive in most cases when you look at a per event basis. But if you look at the amount of revenue that you're getting from irrigation, particularly in arid areas, they might be closer. They're certainly an order of magnitude similar, in my opinion. But the labor and the next irrigation is what's right in front of you. That's the problem you have to solve today. And the whole season is something that you looked at that problem 3-4 months ago, and you might look at it again 3 or 4 months from now. It's addressing that difference in the value of water is challenging, because you've got to look at two very different timescales and two very different sort of problems. One's regulatory, organizational, the other is more practical. How do we get that valve open today versus how do I know what my water deliveries are going to be over the next 12 months?
I also had another question around, so when people set up their irrigation systems, do they set them up every year? Do they set them up every 5 years? How often do they, I guess, turn over their irrigation systems, and what type of investment is an irrigation system, and what's the change from, I guess, a status quo to what, we ideally would like to have people use when it comes to conservation?
There's a lot of variability in that, and it really depends on the crop production system and the irrigation technology itself. For example, there are pivots that are 50 years old and still work well enough. You replace the sprinklers every couple of years, but the steel's doing fine. In almond orchards, you should expect a 10 or 20-year lifetime out of the trees and 10+ years out of the irrigation system if you're using drip. But if you compare that to vegetable growers in Salinas, they're using single-use thin wall drip tape. So they're putting out a new system every year, sometimes more than once a year. And there's, a lot of variability in between. I worked with a grower or interacted with a grower a few weeks ago who's using gated pipe that was probably 30 years old. And it works for him. I have no idea how efficient it is, but it's efficient enough for his needs. So there's a lot of variability in terms of how long do these systems last and the timescales that people look at when they're thinking about them.
I also want to talk about, so a lot of agriculture businesses are very risk adverse. And I think kind of it captured that there's, he has this old system and it works and he's making money. So why change it? How, is there a way to, take a risk adverse farmer and say, all right, we'll take some of the risk if you adopt this new technology? We've seen that like in the energy space where, you have government backed financing on certain projects. Is there anything like that happening or?
I I have seen it. I haven't seen it a lot. I'd like to see it more. There was an irrigation consultant in Oregon that I worked with for several years, and part of his sort of business strategy was that when he started working with a grower who hadn't adopted any technology really, he basically, his offer was, you put my service on your farm and we'll share the savings. I'll show you that you're making more money than you were, and we'll split the difference, and I'll keep some of what you've made. If your gains are 10% over your old or 20% over your old gains or your own revenue, he would take a percentage of those gains. So he wins if the farm wins. I've seen that certainly work well for him. But that risk is, for some growers, for some technologies, that risk can be profound because it can have very, very lasting effects. If you're in an almond orchard and you're, just coming into production, it's been 5 years, you're not making much revenue, and somebody comes along with a new technology and they say, you try this, if it doesn't work, it doesn't cost you anything. If it kills the trees, it's cost you a whole lot. So you may not have paid anything for the technology, but if you can't grow anything on that ground after using it, that's not a risk. That's a disaster.
I imagine it'd be hard to compensate someone for that too.
It's very expensive.
I have another question. So what's something the technology that you're really excited about? What's something that you're like, hey, this is really cool, and I hope more people look at it?
So I'm a software guy. I'm really excited about algorithms and software stuff. One of the things that I'm excited about is getting more out of the low-cost soil moisture sensors and getting that data faster and more often. The getting daily or hourly soil moisture measurements is something we've had for 20 years. And they're really useful. You can do a much better job. But if you had soil moisture measurements at multiple levels, right? And then there are probes that are out there that do that. They've been around for a while. If you can measure those probes once a minute rather than once an hour or once a day, that opens up a lot of management things that weren't available before, because now you can look at the very, very small timescales associated with infiltration problems. Right? When you turn on your irrigation system and the water starts coming out and going into the soil, the rate at which that happens and how much runoff happens and how much deep percolation happens depends a lot on the soil, and you can't see it happening. I mean, you could see runoff happening, but if it's, a couple millimeters and the water's moving real slow, it doesn't look that bad. But over the course of a whole season, and you add it all up, it could be pretty bad. I see some opportunities in having those data measured at a much higher rate so that you can start simulating and quantifying the other physical processes associated with irrigate or with infiltration. That's something that I'm working on. I know there's a few other researchers that are working on it. And that basically will manifest as a new algorithm that we could just give away to anybody who's willing to use it. but the who in that case is the soil moisture sensor manufacturers. So, we wouldn't take the normal extension oriented approach with those technologies, but that's something that I'm interested in and excited about.
Yeah, that sounds really cool. Dan, you had another question?
Yeah, thank you. I hope I'm not asking too many questions here. Is there any interest in looking at the dynamics of the system as far as if there is a failure of a valve so that the particular system doesn't turn on, or if there is a leak because of bursts of piping or hose infiltration? Is there any kind of, are there management systems for that rather than depending on the moisture sensors, probably looking at water flow versus stations and making sure that there's actually water flow or there's not too much water flow?
Yeah, I've seen a couple startups that offer that as a service where they're monitoring flow rate and pressure. And basically they establish some sort of a baseline. And then when the flow and the pressure deviate from that baseline, it triggers additional analyses that might alert the grower to something's wrong. I advocate for adding more sensors further down the sort of the hydraulic line. Having a pressure sensor at the end of the pivot can be wonderfully useful if you're trying to figure out if a coyote's yanked one of the drop tubes off the pivot, because the pressure will be too low at the end of the pivot. The same is true for drip systems. Having a couple extra pressure sensors can tell you if the flow rate's right. Maybe you need to do some flushing, or you've got some clogging, or the coyotes and the gophers got to some of it and the flow rate's way too high.
Nature got you.
Yeah, birds too will do it. So yeah, there's definitely value to that. There's also extra cost, and it's not just the cost of the widgets, it's the cost of having even more data that you have to figure out what to do with it on your own.
So talking about like how crops and irrigation is going, how prevalent is the switch from row crops to like fruit and nut crops? Around our region, there's been a huge switch from corns, rice towards like almonds, walnuts, and peaches. And you can see a kind of a huge change from flood and channel irrigation to drip irrigation. Has cotton farming around Bakersfield disappeared, for example, or
Hasn't
how?
disappeared. It's certainly not as much as it once was. That trend, at least in California, has been going on for a really long time. The answer is simple. You can make more money with almonds than you can with corn. Sigma, I think, is going to change that calculus. The risk associated with not having enough water is much higher in a permanent crop. You've got
And
a
Sigma,
10-year-old almond orchard, you can't afford to lose it. And so the calculus of how much water do we need is different. You can't abandon an almond orchard. You can get insurance for an annual crop like corn, such that it's not a bankruptcy inducing event if you have to abandon the crop. And that's, in the Midwest and you think about the states in between Colorado and Kentucky, that's not an uncommon thing. You have bad years, and if you've got insurance and you've got sort of safety net sort of agencies out there, then it's not the end of the world if you've got to abandon your crop.
oh, I mean, oh yeah. So you mentioned Sigma there. That's the Sustainable Groundwater Management Act passed in California, I think in 2014, which I like to think of as water's version of a cap and trade, which is internalize the negative externality through a Pagovian tax in our unique Californian way. Do you have any other questions from the audience that we want to ask before we wrap this up? All right. And with that, I want to ask you, what are you most hopeful for with the sustainable groundwater management in Californian water?
I am hopeful that Sigma will make sustainability something that's permanently baked in to irrigation system design and management. I think if we can find some way to monetize being sustainable, it'll go on forever and it'll be great in my mind. I For me, sustainability means we can keep doing what we're doing forever. And that's a challenging sell because, it'd be nice to think that my farm is going to last for the next 100 years, but I've got to get through this year. And balancing those competing needs of this year, things don't look that great. And next year, hopefully they'll be better. And 50 years is so far away, I'm not going to worry about it right now. If that were baked in, I think that would be great. That's what I'm excited about with Sigma.
You know, that does sound like it's an excitable time or an exciting time in water in California and agriculture. And with that, I want to tell people to go check out the Wet Center at Fresno State. Go check out the Center for Irrigation Technologies. Look up Dr. Charles Hillyer here. Is there a way that they can contact you if they have questions?
They can reach out to us through our website. I think you're free to share my email. I'll put it in the chat right now. I warn you that I get more emails than I can read,
Well,
but I will try to do my best to reach out to everybody who reaches out to me.
and you can sign up to, I believe the Wet Center and the Center for Irrigation has an email list that they do send updates to, and they have
Yes.
events. So you can go there, check out the new technologies, see their testing center, and get connected with it. And with that, I want to give a big round of applause to Dr. Charles Hillyer, and thank you for joining us today. I also want to thank our supporters. That's SMUD, Chico Start, Fresno State, Witten Law, Moss Adams, and River City Bank, and then encourage people to join us at the upcoming discussions around water, which we will have more people from the Center for Irrigation Technologies and the Wet Center coming and talking about the projects and how they're working on and how water regulation is impacting a lot of farms in the Central Valley. Also, if you have a startup, we have a great workshop with Stoll Reeves, Getting Capital Ready in Trying Times, Legal Essentials for Entrepreneurs. You can go and check those out at cleanstart.org, and you can sign up for our newsletter. So I want to thank everyone for attending and encourage you all to connect with us. We have Instagram, I'm told, and Facebook, along with LinkedIn, YouTube. This little one right here, that is the Innovation Network or Empower Innovation, funded by the CEC, which we are under the CEC's Innovation Cluster at the Wet Center there, and our website. So with that, thank you very much. Thank you, Dr. Hillyer, for joining us, and everyone have a great day.